Welcome back for another physics video. Today we're going to be talking about static electricity again, and the topics I'll be covering with you involve charge interactions, conductors and insulators, and polarization, which is where you induce charge. By rubbing this balloon with rabbit fur, I can charge the balloon and it will then attract these styrofoam pellets. Charge produces a non-contact invisible force called the electric force. The electric force is similar to the gravitational force, except that the electric force can be both an attractive force and a repulsive force. The law of attraction and electricity goes like this. Like charges repel and opposite charges attract. If you have a positive charge and it comes into contact with another positive charge, then it will repel with an equal and opposite force. Similarly, if you have a positive charge and it comes in contact with a negative charge, it will attract with an equal and opposite force. The equal and opposite force is due to Newton's third law of motion. Forces come in pairs. And so the law of attraction in electricity is that likes repel and opposites attract. But what if you have a charged object that comes in contact with a neutral object? The answer to that question is that any charged object, whether positively charged or negatively charged, will always attract a neutral object. The behavior of a charged object depends on whether the object is a conductor or an insulator. All right, here I'm going to demonstrate the difference between a conductor and an insulator. So here's a metal, and it's conducting electricity quite well. Here I have a light bulb that I'm lighting up because of the metal. And a fluorescent bulb. Here's an eraser, and you'll see it doesn't conduct electricity well because it's an insulator. Here's something else that's plastic. Here's a wood box. It doesn't conduct electricity well. But nothing is a perfect conductor or a perfect insulator. So keep that in mind. Given enough electricity, enough voltage, you can cause the electrons to move in any object, whether it's a conductor or insulator. The behavior of a charged object depends upon whether the object is a conductor or an insulator. Conductors are objects that allow electrons to flow easily from particle to particle. When excess charge comes in contact to a conductor, it will spread out uniformly all over the surface of the conductor. Insulators, on the other hand, do not allow electrons to flow easily from particle to particle, and when excess charge comes into contact with an insulator, it will remain at the initial location of charging. Conductors and insulators, they lie on a spectrum, with metals such as silver and copper being superconductors. Then you have carbon, which acts as a semiconductor, and silicon would be right here with a semiconductor. And then you get down water, especially tap water, would be right in the middle of the spectrum. And you get down to insulators with things like air, glass, and plastic being the best insulators. The electrons in a conductor can be induced to move from one end to another end on a conductor. So here is an example of induction, where you induce the charge in a conductor, this is representing a conductor, to move to the other end. So you bring this negatively charged rod toward this metal conductor, and the negative electrons will move to the other end. And so now you have positive charge separated from negative charge. This separation of positive and negative charge is called polarization of a conductor. You can also get polarization in insulators, but the way that it happens is different than the way it happens in conductors. In insulators, the charge on the molecules or atoms themselves becomes separated to produce a positive or negative charged insulator. So here's an example of the wall, or I'm getting ready to show you a stream of water, and these represent the water molecules. And so the atoms that make up the molecules themselves separate out their charge. The electrons don't actually leave the molecule, they just rearrange themselves inside of the atom itself, or the molecule itself, to cause one side of the molecule to have positive charge. This is polarization of an insulator. I'm getting ready to show you what that looks like with a stream of water and its charged up balloon. So you got.
I'll edit this, okay? And I'll make sure.
So I'm getting this balloon real good and charged, and then my daughter's going to pour a stream of water, and we're going to watch it bend. Don't forget to pour it slowly. Okay, you ready? Go ahead and start pouring it slowly. Oh, whoa, look at that bending. Do you see that water bending? Oh, that's neat. If you didn't see it, then that's something you could try at home. Charge up a balloon with your hair and use the sink and turn the sink on low, and you'll see the polarization is not charging an object, rather it's simply a redistribution of balanced charge. Balance of charge results because there's an equal number of positive charge and an equal number of negative charge. So you'll see 1, 2, 3 positive charge, 1, 2, 3 negative charge, and so there is a balance of charge. It's just that the charge is separating at the end of the object, and that's what happens during polarization of a conductor. Same thing with polarization of an insulator. It's not that you have an excess of positive and negative charge. It's just that the positive and negative charge has redistributed itself inside the atoms and molecules such that the atoms and molecules will attract or repel to another object.
I didn't even read it.
All right, guys, let's wrap this lesson up by reminding you what I talked about. I talked about how like charges repel, opposite charges attract. We also talked about conductors and insulators, and I told you a little bit about the polarization of a conductor and an insulator. Your next lesson, we'll look at different methods of charging objects, so please stay tuned. See you next time. Bye.
Okay.